60 minutes. That's all you have. 60 minutes before the light that left your eyes right now reaches the edge of what we call the observable universe? No. Wait, that's wrong, and that's the point. It would take that light 46 billion years to get there, and by the time it arrived, the place it was aimed at wouldn't even exist anymore. It would have moved. Everything moves. Everything is running out of time, including you, right now, in this room, on this rock, spinning at nearly 1,000 miles an hour without you feeling a thing. Here's what happened. Somewhere in the last few minutes, without asking your permission, the Earth carried you about 16 miles through space, just from spinning in place. And that's the small stuff. That's the part that doesn't even register on the scale we're about to walk through. Because in the next few minutes, I'm going to take you on a countdown, not toward an explosion, not toward a deadline, but toward a truth most people spend their entire lives successfully avoiding. And once you see it, you cannot unsee it. Before we begin, if you're the kind of person who needs to understand exactly where you stand, literally, cosmically, permanently, take a second to like and subscribe. It helps this reach more minds like yours, the ones who don't flinch from the big questions. Here's the countdown. We start at 0, which is you, right now, breathing, sitting, existing on a planet that feels. From where you're standing, enormous, infinite even, the ocean disappears past the horizon. Mountains take days to cross. A single country can swallow your entire life without you ever seeing all of it. Earth feels big because your body was built at a scale where big means bigger than me. But that feeling is about to become the first casualty of this countdown. Because the moment we start moving outward, the moment the clock starts running, Earth stops being a world and starts being a number. And the number is smaller than you can currently imagine. At minute 1, we leave the ground. Not with a rocket, not yet, just with math, which is faster and cheaper and doesn't need fuel. We rise until the curve of the Earth becomes visible, that thin blue line astronauts talk about with their voices cracking. From up here, the entire theater of human history, every war, every wedding, every funeral, every civilization that ever rose and ever fell, all of it happened inside a surface area you could now trace with your finger from a single window. 25,000 miles around the equator. That's the whole story. That's the entire stage. And already, something in your chest should be tightening, because we've barely started the clock. At minute 5, we've crossed into what people casually call space, though that word is about to lose all its casualness. The distance from the surface of the Earth to what's technically defined as space, the Kármán line, is 62 miles. 62 miles is roughly the distance some people drive to work, meaning the barrier between on Earth and in the vastness of the universe is thinner than a lot of daily commutes. Think about that for a second. The fragile shell of air that lets you breathe, that separates every living thing you've ever known from the total silence of a vacuum, is not some cosmic fortress wall. It's a windshield. And it's getting thinner every year. But that's not the important part yet. Hold on to that thought. It's going to come back. And when it does, it's going to hurt more than it does right now. At minute 10, the pressure starts. We're no longer just rising, we're accelerating outward. And every few minutes on this clock, the scale we're dealing with is about to jump by orders of magnitude that the human brain was never built to process. Here's what most people don't realize. Your brain, the same brain reading, hearing these words right now, evolved to judge distance by throwing spears and estimating how far a lion could run before lunch. It was never meant to hold 62 miles and 46 billion light years in the same thought without breaking something. So we're going to build the ladder slowly, rung by rung. Because if I threw you straight to the top right now, your mind would simply refuse the number. The way a smoke detector goes silent if you disable it instead of dealing with the fire. At minute 15, we clear the moon. 238,000 miles away, a distance so casually thrown around in science documentaries that people forget what it actually means. Imagine you're driving a car at highway speed, 70 miles an hour, no stops, no sleep, no bathroom breaks, forever. It would take you almost 6 months of non-stop driving just to reach the moon. 6 months. For the one object in the night sky that feels to us close enough to touch. And already, at this ridiculously early stage of the countdown, you should be feeling the first crack in your intuition. Because if the moon, the nearest, most familiar object beyond Earth, requires half a year of ceaseless driving, then everything after this is going to require numbers your car analogy simply cannot survive. Here's the question. If you had exactly 1 hour left to communicate everything meaningful about your life to another civilization, somewhere far enough away that your signal would take generations to arrive, would you tell them the truth, the beautiful and ugly parts together? Or would you tell them only the beautiful parts, so that whatever they built of you in their imagination would be kinder than the truth deserved? Some would say the truth is a form of respect, that any species advanced enough to receive a message deserves the whole picture. Others would argue that a message sent across such distance is really a message to the future, a kind of time capsule. And time capsules are meant to be hopeful. There's no easy answer here. It depends entirely on what you think communication is actually for. At minute 18, before we reach the sun, there's a stop most people skip entirely. And skipping it is a mistake, because it's the last chance your intuition gets to feel like it's keeping up. Between the moon and the sun, in the same rough neighborhood as Earth, sit the other rocky worlds, Mercury, Venus, Mars, and none of them, on their own, break your sense of scale. Mars is smaller than Earth. Mercury is smaller still. You can hold these in your head without strain. But keep going outward, past the asteroid belt, a scattered ring of rubble between Mars and Jupiter. Leftover material that never quite finished becoming a planet, and you hit Jupiter, and Jupiter is where the first real gut punch of this countdown happens. Jupiter is so large that it could fit more than 1,300 Earths inside its volume. 1,300. Imagine you're standing on the surface of Jupiter. You couldn't. It's a gas giant with no solid ground. But imagine it anyway. And looking up at a storm system called the Great Red Spot, a hurricane wider than the entire Earth, that has been raging continuously for at least the last 190 years and possibly far longer. A storm older than photography, older than the telephone, older than most of the buildings still standing in most of the world's oldest cities, and it hasn't stopped once. And Jupiter isn't even the biggest thing in our own solar system besides the Sun for very long once you start comparing it to what's out there past it. Saturn, with its rings built from billions of individual chunks of ice and rock, some as small as a grain of sand, some as large as a house, all orbiting in a disk so thin that if you scaled Saturn down to the size of a basketball, the rings would be thinner than a sheet of paper. Uranus, tilted almost completely on its side, likely from a catastrophic collision earlier in its history, meaning its seasons last over 20 years each, and a single day there is a tangle of light and dark that no human calendar could comfortably describe. Neptune, the windiest place we've ever measured in the solar system, with storms clocked at over 1,200 miles per hour, faster than a bullet fired from most rifles, on a planet so far from the sun that sunlight itself takes over 4 hours just to arrive, meaning if the sun vanished this instant, someone standing on Neptune wouldn't even know it happened until 4 hours later. Here's what most people don't realize about all of this. Every planet we just walked through, Mercury through Neptune, every ring, every storm, every moon, all of it together still orbits inside a region so small compared to what's coming that it barely counts as a rounding error yet. We haven't even left the driveway. And that's the trap this countdown is built to spring on you. Each stop feels enormous in the moment, and each one becomes almost embarrassingly small the instant we take the next step outward. The sun sits 93 million miles away. To put that in something your body can hold, if the 6-month non-stop drive to the moon felt long, reaching the sun at that same relentless highway speed would take you around 150 years. You would not survive the trip. Your grandchildren might not survive the trip. And yet, on the cosmic scale we're about to enter, 93 million miles is nothing. It is a rounding error. It is the distance between two people standing in the same room compared to what's coming next. And if you thought that gap between nothing to us and everything to us was uncomfortable, wait, because it's about to get worse. Meanwhile, something else is happening that most people never even think to ask about. While you've been sitting here listening, the sun has been quietly converting 4 million tons of its own mass into pure energy every single second, just to keep every living thing on Earth alive for one more day. 4 million tons every second. It has been doing that for 4.5 billion years, and it has enough fuel left to keep doing it for roughly 5 billion more. So the sun isn't just a light in the sky. It's a countdown of its own. A slower, older, far more patient one than ours. And one day, long after every name you've ever heard has been forgotten, it will swell, and it will consume the very ground you're standing on right now. Here's the part that turns this from a distant fact into something personal. Every heavier element in your body, the calcium in your bones, the iron in your blood, the oxygen you just breathed in without thinking about it, none of it was made in the Big Bang. The early universe could only produce the lightest elements: hydrogen, helium, a trace of lithium. Everything heavier had to be forged later, inside the crushing furnace of a star's core, built atom by atom over millions of years of nuclear fusion. and then scattered across space in the violent death of that star, sometimes in a slow bleed, sometimes in a supernova bright enough to briefly outshine an entire galaxy. Imagine you're tracing a single iron atom in your own bloodstream backward through time right now, not metaphorically, literally. The actual atom sitting inside a red blood cell somewhere in your body at this exact second. And imagine that trace leading you, eventually, to the final moments of a star that died before our sun even finished forming, scattering its guts across the galaxy so that 5 billion years later, some of those exact atoms could end up assembled into something that can sit still long enough to feel awe about it. You are not separate from the stars. You are their leftovers, rearranged into something that can ask questions. That's not poetry. That's nuclear physics with the emotional weight left in on purpose, because leaving it out would be its own kind of lie. That's not even the real story, though. Hang on to that thought. It's going to be important, because the death of the sun is small news compared to what's coming. At minute 30, we're halfway through this hour, and the stakes just quietly doubled, because now we're leaving the entire idea of our solar system behind and stepping into the space between stars. Here's where things get uncomfortable. The nearest star to our sun, a red dwarf called Proxima Centauri, sits about 4.24 light-years away. A light-year isn't a measurement of time, even though it sounds like one. It's a measurement of distance. Specifically, the distance light travels in one full year, moving at 186,000 miles every single second. If you tried to drive there at highway speed, non-stop, forever, it would take you over 50 million years. 50 million years ago, there were no humans. There wasn't even a recognizable ancestor of humans. The entire history of our species, every pyramid, every language, every love story, would need to happen 50 million times over, back to back, just to cover the drive to our closest stellar neighbor. And that's the closest one, the nearest star in a galaxy that contains, conservatively, 100 billion others. Think about that for a second. Not skim past it, actually sit with it. 100 billion stars, and the closest one is already functionally unreachable by anything we currently know how to build. This is the moment in the countdown where most people's intuition simply gives up, and honestly, that's the correct response. Your intuition should give up here. It was never built for this. What matters now isn't whether you can feel the true size of this. Nobody can. Not really. What matters is whether you keep going anyway. At minute 32, before we leave the neighborhood entirely, there's a piece of the puzzle most people skip past. And skipping past it is exactly why the next few numbers are going to hit harder than they should. Past the orbit of the outermost planet, there's a region called the Kuiper Belt, a frozen debris field stretching billions of miles, home to Pluto and thousands of other icy little worlds nobody named because nobody's finished counting them. And past the Kuiper Belt, there's something even stranger, the Oort cloud. A theoretical shell of icy debris that may extend nearly a full light year from the sun in every direction. 1 light year. Meaning our own sun's gravitational influence, the outer edge of what we could reasonably call our solar system, reaches almost a quarter of the way to the nearest star before it finally lets go. Imagine you're one of the 2 Voyager probes, launched in 1977, older than most of the people watching this right now, still transmitting, still moving outward at roughly 35,000 miles per hour. And even after nearly 50 years of nonstop travel, you still haven't fully cleared the Oort cloud. You won't clear it for another 10,000 years. 10,000 years just to leave the porch light of your own house. Here's what most people don't realize about that fact. It means humanity's fastest, farthest traveling machine, the one object we've built that has genuinely left the neighborhood of the planets, is still, right now, at this exact second, closer to your kitchen table than it is to the next star system. Not close in any way your body understands as close. Just less impossibly far. That's the only kind of close available at this stage of the countdown, and it only gets less available from here. By minute 40, the pressure in this countdown has become almost unbearable because we're no longer talking about stars one at a time. We're talking about the Milky Way itself, our home galaxy, the thing that looks from the outside like a flattened spiral of light, with our entire solar system sitting quietly in one of its unremarkable outer arms, nowhere near the center, nowhere near anything special. The Milky Way stretches about 100,000 light years across. Not miles. Light years. Meaning, if you could somehow move at the speed of light itself, 186,000 miles every second, the fastest anything is physically allowed to move in this universe, it would still take you 100,000 years just to cross from one edge of our home galaxy to the other. At hour 40 of our 60-minute clock, we haven't even left home yet. We're still inside the house, and the house alone would take longer to walk across than the entire existence of modern humans. And here's the part that should genuinely unsettle you. On a clear night, when you look up and see that faint, hazy band of light stretching across the sky, the one ancient cultures called a river of milk, a road of souls, a spine of the sky god, you are looking at maybe a few thousand of those 100 billion stars. And even that handful is more light than your eyes can properly separate into individual points. Your entire species has spent its entire existence unable to see more than a thin, blurred smear of its own galactic home. Not because the stars aren't there, because they're too far away, and too many, for a creature built to judge the distance of a thrown spear. At minute 42, we push toward the actual center of the galaxy, roughly 26,000 light years from where you're sitting right now, and at the center of that center sits something the entire structure of the Milky Way quietly orbits. A supermassive black hole named Sagittarius A star, with a mass over 4 million times that of our Sun, packed into a region smaller than the orbit of Mercury. Nothing that crosses too close to it ever comes back. Not light, not matter, not information of any kind. Every star you've ever wished on has spent its entire existence slowly circling that darkness. The same way water circles a drain, just impossibly slower, over a timescale of hundreds of millions of years per orbit. And here's the part most documentaries leave out: the visible stars, the ones we can actually count and photograph and name, only make up a small fraction of the Milky Way's total mass. The rest, by some estimates, roughly 85% of everything holding this galaxy together, is something we call dark matter. A substance we cannot see, cannot touch, cannot directly detect with any instrument we've built, and can only infer exists because without it, galaxies like ours would fly apart entirely. Meaning most of what's keeping your own galactic home from tearing itself to pieces is made of something science still cannot fully explain. Think about that for a second. The invisible outweighs the visible 5-1. In the very structure that holds your sun in its orbit. Here's the second impossible question, and it's the one that tends to follow people home after they hear it. If you learned beyond any doubt that 95% of the universe is made of dark matter and dark energy, things we cannot see, cannot touch, and may never fully understand, would you rather know the universe is mostly built from mystery, or would you prefer the comforting lie that we've basically figured it out? Some would say the truth is worth the discomfort, that humility in the face of the unknown is the most honest posture a species can take. Others would argue that a species needs the confidence of we've mostly got it to keep funding the telescopes, the missions, the next generation of scientists who might actually solve it. There's no easy answer. It depends on whether you think progress runs on humility or on hope. At minute 45, we hit the second false ending of this countdown, and I want to be honest with you about that. So that's what it would really take to understand the scale of just our own galaxy. A home so large that light itself needs 100,000 years to cross it, built from 100 billion suns, one of which happens to keep you alive. Wrapped around a black hole so massive it can bend the light of everything that gets too close. If you found that valuable, if something in your chest tightened the way it should have, take a moment to like and subscribe. But before we end, there's something else you need to understand, because everything we've covered so far, Earth, the moon, the sun, the nearest star, the entire Milky Way, all of it, every last atom of it, is about to become a rounding error of its own. At minute 50, the real pressure begins, because the Milky Way is not alone. It sits inside something called the local group, a cluster of more than 80 galaxies bound together by gravity, dominated by two giants, our Milky Way and the slightly larger Andromeda galaxy, which is currently racing toward us at about 250,000 miles per hour, on a collision course that will fully merge the two galaxies in roughly 4 to 5 billion years. Meanwhile, the local group itself is just one small suburb inside something called the Virgo Supercluster, which contains around 100 trillion stars across thousands of galaxies. And the Virgo Supercluster is just one filament inside something even larger, the Laniakea Supercluster, a structure so vast that it wasn't even properly mapped by scientists until 2014, meaning for the entire history of human civilization before that point, nobody on Earth knew the true name or shape of the very neighborhood they lived in. Here's the question, and it's the hardest one in this countdown. If you discovered, with absolute certainty, that intelligent life exists somewhere in one of those 100 trillion stars, but you also discovered that no message, no signal, no ship could ever reach them in less than several human lifetimes, would you still want to know they exist? Some would say yes, that certainty of not being alone is worth any distance, any silence, any wait. Others would argue that knowledge without contact is its own kind of loneliness, a cruelty dressed up as comfort? There's no easy answer. It depends on whether you believe that meaning requires connection, or whether meaning can survive on knowledge alone. At minute 52, we zoom out one more time, and this is the point in the countdown where even trained astronomers admit the numbers stop feeling real. Beyond the Virgo supercluster, beyond Laniakea, the universe arranges itself into something called the cosmic web, a structure of filaments, threads of galaxies, hundreds of millions of light years long, strung together like the world's largest, coldest spiderweb, with enormous empty regions called voids stretched between them. One of these voids, the Boötes void, is so large and so empty that if our own Milky Way sat at its center, we wouldn't have discovered other galaxies existed until the 1960s. Simply because there would have been nothing close enough to see with the naked eye. Imagine you're a civilization that evolved inside a void like that. Your entire understanding of the universe, your entire mythology of everything that exists, would be built around a night sky with almost nothing in it. You would look up, see a handful of distant smudges of light, and reasonably conclude that you were utterly, completely alone in all of creation, and you would be wrong. Not because of anything you did, but simply because of where in the cosmic web you happen to be born. That's the part that should stay with you. Some of the loneliest possible perspectives in this universe aren't a matter of truth. They're a matter of address. Here's the third impossible question, sitting right at the 3/4 mark of this countdown, and it's the one that tends to divide a room the most. If you learned that our entire observable universe, every galaxy, every star, every filament of the cosmic web, occupies less than 1% of what actually exists beyond the edge we can see, and that the rest is permanently, structurally unreachable and unknowable by any means available to any civilization ever, forever. Would you call that universe infinite, or would you call it, for all practical purposes, exactly the same size as the tiny sliver we can actually observe? Some would say size only matters if it's reachable, that a universe you can never touch may as well not exist for you at all. Others would argue that true size doesn't care what we can access. That reality doesn't shrink just because our instruments run out of range. There's no easy answer here. It depends on whether you define real by what exists, or by what can ever reach you. Meanwhile, something else is happening at this exact moment in the countdown that almost nobody accounts for. The universe isn't just large. It's getting larger, and it's accelerating while it does it. Distant galaxies aren't just far away, they are moving farther away from us every second, and the rate of that expansion is increasing, driven by something scientists call dark energy. A force we can measure the effects of with total confidence and cannot explain the cause of at all. It makes up roughly 68% of the entire energy content of the universe, more than everything else combined, and we do not know what it is. Not we haven't finished studying it yet. We do not know, at the most fundamental level, what the majority of existence is actually made of. Imagine you're an engineer handed a machine that works perfectly, that you can measure with total precision, and told that the part responsible for 2/3 of its function is completely unlabeled, unidentified, and possibly unidentifiable. That's the universe. That's the box we're all living inside of right now. At minute 55, we arrive at the edge of everything we can actually observe. The observable universe itself, a sphere roughly 93 billion light-years across, centered, by definition, on wherever the observer happens to be standing. That's not arrogance. That's physics. Because light has a speed limit, and the universe has an age, roughly 13.8 billion years, there is a hard boundary past which no information could possibly have reached us yet, even if it left the very moment the universe began. Beyond that boundary, more universe almost certainly exists. We simply cannot see it, cannot measure it, cannot ever prove what's there. Because the light hasn't had time to arrive, and by the physics we currently understand, it never will. Somewhere out past that boundary, there could be another Earth. There could be nothing at all. There could be laws of physics so different, they'd make our version of reality look like a rough draft. And we will never know. Not because we haven't built the right telescope yet, but because the universe itself has made that knowledge permanently, structurally impossible to obtain. We're now standing inside a universe that contains an estimated 2 trillion galaxies, each one holding, on average, 100 billion stars, meaning the observable universe alone contains something in the neighborhood of 200 billion trillion stars. A number so large that if you tried to count them one per second without stopping, without sleeping, without ever pausing to eat, you would still be counting for tens of thousands of times longer than the entire universe has existed. That number, sitting quietly in the sky above you every single night, is the true size of the thing you've spent your whole life calling the sky. At minute 56, with the clock nearly gone, there's one more layer that most people never get to, and it might be the strangest one of all. If you point a sufficiently sensitive instrument in literally any direction in the sky, it doesn't matter which way, all directions give the same answer. You will detect a faint, ancient glow called the cosmic microwave background. The leftover heat from the universe when it was only 380,000 years old cooled over 13.8 billion years into microwaves instead of visible light. It is, in a very real sense, a baby photo of everything that exists, and it is remarkably, almost suspiciously smooth. Nearly the same temperature in every direction to within 1 part in 100,000. That smoothness is a problem because regions of space on opposite sides of the observable universe are far enough apart that light hasn't had time to travel between them and even out the temperature, and yet somehow they match almost perfectly anyway. The leading explanation is something called cosmic inflation, a period fractions of a second after the universe began. When space itself expanded faster than the speed of light, stretching a tiny patch of near-uniform heat into the entire vast, smooth backdrop we now measure. And if inflation happened once, in one patch, some of the leading theories in modern cosmology suggest it may still be happening elsewhere, endlessly, spinning off other patches of spacetime, other bubbles, other universes with potentially different laws of physics, forever inaccessible to us, forever unconfirmable, forever just outside the edge of what we're allowed to know. Nobody watching this can prove that's true. Nobody can prove it's false either. It sits in that strange, uncomfortable territory where the math works, the logic holds, and the evidence remains permanently out of reach. Here's the fourth and final impossible question, right before this hour runs out completely. If multiple universes exist, each with different physical constants, different starting conditions, different odds of ever producing something capable of asking, "Why am I here?" And if the only reason our particular universe seems so perfectly tuned for stars, chemistry, and life is that we could only ever exist in a universe where those constants happen to work, would that make your life more meaningful? Because you're an extraordinary, vanishingly rare outcome, or less meaningful? Because somewhere among infinite other bubbles, infinite other versions of this exact moment are happening in every possible way, good and bad, all at once, without any one of them being special? Some would say rarity is exactly what creates meaning, that being the improbable exception is the whole point. Others would argue that if every possible version of you exists somewhere, then no single version, including this one, including you, right now, gets to claim it matters more than any other. There's no easy answer. It depends on whether you think meaning comes from being unique, or whether meaning has to be earned regardless of how many copies might exist elsewhere. Thank you for staying with this exploration of just how small and how impossibly large everything actually is. But before we close this out, there's one more piece we haven't put in place yet, and it's the piece that changes what all of this means. At minute 58, we come back to that thin blue line we saw in the very first minute of this countdown, the atmosphere. The 62-mile windshield separating everything you've ever loved from the total, airless silence of space. Remember that thought I asked you to hold on to? Here it is. Every person who has ever lived, every civilization that has ever risen and fallen, every war fought over a border, every fortune built, every heart broken, all of it happened inside a shell of breathable air so thin that if you shrank the Earth down to the size of a basketball, the atmosphere would be thinner than a coat of varnish. That's the entire habitable universe as far as we currently know for certain. Not the 200 billion trillion stars. Not the 93 billion light-year sphere. Just this. This varnish. This one, single, extraordinarily fragile coat of air wrapped around one unremarkable rock, orbiting one unremarkable star, in one unremarkable arm of one galaxy among 2 trillion. And somehow, against odds too large to honestly calculate, inside that varnish, something happened that, as far as every instrument we've ever built can tell, has not happened anywhere else in 200 billion trillion other possible locations. Something started asking questions. Something built telescopes to stare at its own irrelevance and call it wonder instead of despair. Something looked up at a sky it could never fully cross, and instead of looking away, kept looking. At minute 60, the clock runs out, and here's where the countdown ends, but not the way countdowns usually end. There's no explosion, no rescue, no final twist that makes everything feel resolved. What you're left with, instead, is the actual size of the room you've been living in your entire life finally lit up all at once. Earth, which felt infinite when you were a child, is smaller, relative to the observable universe, than a single grain of sand is to every beach and every desert on this planet combined, measured together at the same time. And yet that grain of sand is the only place in the entire 200 billion trillion star reach of everything we can see where we know with total certainty that someone is standing right now, listening to these words, feeling something they can't quite name. In the end, what matters isn't the size of the universe against the size of our planet. It's what we do with the strange, brief, improbable fact that we're here at all, on this one grain, inside this one thin coat of breathable air, awake enough to ask the question in the first place. Consider what that actually required. Consider that this exact grain of sand needed to sit at exactly the right distance from exactly the right kind of star. Needed a molten iron core spinning fast enough to generate a magnetic field strong enough to deflect the worst of that star's radiation. Needed a moon large enough to stabilize its tilt so its seasons wouldn't swing wildly enough to sterilize it. Needed billions of years of chemistry running quietly in the dark before anything resembling life took its first breath. And needed that life to survive at least 5 separate mass extinctions, any one of which could have ended the entire experiment before it produced anything capable of building a telescope, let alone using one to stare at its own insignificance and call it beautiful instead of unbearable. If this moved you, if it challenged the way you've been carrying around your own sense of scale, please take a moment to like and subscribe, not because the algorithm needs it, but because there are more grains of sand out there worth exploring together. And every one of you watching is proof that somewhere, against every number we just walked through, the universe occasionally looks back at itself and wonders what it's looking at. 60 minutes. That's all it took to go from a rock that felt infinite to a universe that makes that rock disappear. And somehow, impossibly, you're still here, still breathing, still inside the Varnish, still, for now, the only known place in all 2 trillion galaxies where anyone is paying attention. Tomorrow, the sun will rise the same way it has for 4.5 billion years, and you will probably forget most of these numbers by lunch, and that's fine, that's human, that's expected. But somewhere in the back of your mind, the next time you step outside at night and glance up without really thinking about it, some small part of you will know what you're actually looking at now. Not a ceiling, not a backdrop. A depth with no bottom wrapped around a grain of sand that, against every reasonable expectation the universe ever set for itself, learned how to look back.